Morning, everyone. Thank you for joining the third webinar in our API series. I'm your host, Nicole Phelps. I work in USGS's Water Mission Area as a science communicator. In today's webinar, we'll be talking about APIs, application programming interfaces. We'll give you some background on APIs in general and the OGC API initiative. Then we'll dive into OGC API Processes and the NLDI, Network and Linked Data Initiative. The Network Linked Data Index. Dave Blodgett and Rich McDonald will give us a live demo. Then we'll finish the webinar with about 20 to 25 minutes for live Q&A. We encourage you to submit questions throughout today's call, as we will answer them in the second half of this webinar. If we are unable to get to your question during today's webinar, please send us an email at wdfn@usgs.gov with the subject API Webinar. Today's webinar is being recorded, and the recording will be available approximately 1 week after this event on our website and on the USGS YouTube channel. Find links for all of these on the WDFN blog. All right, let's get started with our first live poll. All right, the link should be in the chat in just a second for this live poll. The question that we are asking you is, which of our API webinars have you seen? And it looks like people have already started to fill it out, so that's great. Sorry about that technical delay. The cool thing about Slido is that we can see the content live, and it'll come up on the screen in just a second. Great. Awesome. So we've had a couple of API webinars already. Which one have you attended? And we're really interested to hear if you attended the webinar live or if you watched the recording. And it looks like this, for most people, is their first one. Now I see we have about 100 attendees right now, and 16 people so far have filled out this poll, but the numbers are climbing pretty quickly. So let's see if we can get about 50 respondents to this one. And then we'll have another question for you in just a moment, and then we'll jump into our first presentation. So it looks like although people keep responding, the distribution is staying pretty much the same. And it's pretty cool to see that a lot of the people who are saying they did attend the previous webinars saw them live, although it does look like quite a few people have seen some of the recordings as well. So we're glad that we're able to provide those so that you can stay in touch with us even if you can't attend the live event. Great. All right, so we've got 60 respondents to this one. I'm going to go ahead and move on to the next one. You should still be able to continue responding to that one as well. So this one, we're interested to hear where you heard about this event. Did you find the event on Twitter? Do you subscribe to the Water Data for the Nation newsletter? Did you see a post about this on Facebook? For those of you who are joining us for the first time and don't know anything about Water Mission Area, we recently got a Facebook. Woohoo! So you may have seen a post on Facebook. We post a lot on Twitter. If you're not familiar with us, you should follow us, USGS_water. Most people, though, have seen us through internal email, which is great. All right, let's try to get at least 30 to 50 respondents to this one. I know most of the time it takes people kind of a couple minutes to join. Oh, a friend. So I see a couple of people are responding to somewhere else. We would love to know where that is. So if you want to go ahead and use the Q&A function in this event, in the live event, to let us know where that somewhere else was. Where did you find us? If not on Twitter, if not from a friend, if not on the WDFN newsletter or an internal email, where did you find us? Great. All right, so we've got 50 responses to that one. Let's go ahead and move on. Give me just a moment. Great. Okay. So again, thank you everyone for joining. Now I'll turn it over to Jim Kraft, Product Manager for Water Data Processing and Web Services. He'll give you some key background information on USGS water data and our APIs. Take it away, Jim.
Thanks, Nicole. Hello, everyone. I'm Jim Kraft from Madison. So why do we care about APIs for water data? To answer that question, let's first talk about the amazing water data that USGS has been collecting for over 100 years, and then we'll talk about bringing together that data in an actionable way. Each dot on the map is an active stream gauge. Take a look at the graph at the bottom of the page. We can see that the number of stream gauges has increased over time, resulting in over 8,000 gauges that are currently active in the USGS network. We're so proud of the work that has gone into this network over time. In addition to the stream gauges, there's a huge amount of spatial data required to appropriately characterize the observational data at our locations. The National Hydrologic Geospatial Fabric Project is trying to provide actionable, machine-readable access to that aforementioned spatial data. This GIF shows one way of looking at the complete multi-scale spatial network of flow paths and hydrologic units across the country. This GIF shows how there is an interconnected network of hydrologic units that completely cover the landscape. Shown here is about 100,000 so-called 12-digit hydrologic units. To give a sense of scale of the information we typically work with, the medium resolution network has over 2.5 million units, and the high resolution network has more like 25 million. With this huge number of features at a wide variety of scales, we need technical solutions that help us work with the smallest individual feature, but also work across these huge networked datasets. The data collected at these gauges and the geospatial data behind them are critical for decision makers. But how does the data get to those decision makers in the format that they need? APIs. They're the magic behind the screen that programmers use, allowing us to communicate between systems. Instead of installing software or downloading data locally on your own machine, APIs allow you to access data or in software running on a server elsewhere. This is beneficial for the API user since the computational load or storage of large data sets are being performed by servers rather than their own machine. Everything you do and see on computers is driven by APIs at a variety of scales. So with APIs, we can answer questions like, are there gauges near flood-prone infrastructure? Are there flow observations upstream of an important water supply? What's the nearest gauge to my favorite whitewater run? What's the overall flow in the watershed upstream of a nearby dam? What rivers are downstream of a contaminant spill? And other critical questions based on water data without having to ask a staff GIS analyst to do these types of spatial analyses. And USGS APIs aren't just for decision makers. We want to make our APIs discoverable, accessible, and usable for people just like you. Do you pull data from USGS systems at regular intervals and use it to make decisions, often in the context of other data in secondary systems? Do you explore and download data, interacting with it in multiple ways, creating various types of analysis? Do you use tools like R and Python data retrieval? You can check out our recent blog post on water data for the nation users. A link to the water data for the nation blog is at the top of this slide and will be shared in the chat. But what's so special about USGS APIs? At USGS, we collect a lot of super cool data that deserves to be properly showcased, of course. And our APIs are specifically designed for just that. Our APIs allow for automated connections between our USGS source systems and your system. You can then build on that connection, interacting with data provided by the USGS with data and tools that make sense for your specific context. In this example, our monitoring location pages are using the API we talked about in a previous webinar on OGC API features to query for real-time monitoring locations that are close to the monitoring location a user is currently looking at. Now, I welcome Dave Blodgett. Dave's a hydroinformatics specialist with our Geospatial Intelligence branch and a project manager for a project called the National Hydro Geospatial Fabric.
All right, thanks, Jim. Let me get my share straight. Excellent. Thanks for having me, and thanks to everyone who's come along today. I'm really excited to get some of this work out there and to share it all with you. In this example, which is kind of a counterpoint to what Jim just had up, our monitoring location pages are using one of the APIs we're talking about today, the network linked data index, to query for upstream and downstream flow lines and a drainage basin boundary, as well as the relationship between the monitoring location and the river. The last two examples, which were built on public web services, so the one Jim showed and this one here, illustrate how we want to offer services that help our users get the most out of our water data in an efficient, effective, and modern way. We want to facilitate the use of USGS data in any system, not just our own, so you can access our data and use it in the way that's most effective for you. So let's dive into the APIs that are really the topic of today's webinar. So the Network Linked Data Index API provides information about how our stream gauges relate to rivers and watersheds. The NLDI can help discover identifiers and addresses along the network. It can navigate along the network given a known starting location. It will retrieve data such as flow lines or stream gauges found along a navigation. And it can return basin boundaries or landscape characteristics associated with any location along the network. But the way the NLDI works is with a defined set of network features, currently about 2.6 million of them. But that only gets us so far, right? Sometimes we need to operate at a greater level of detail. For this, we've developed processes that we represent with this API standard we're talking about today, OGC API Processes. So today we're going to talk about this API Processes that fits under the umbrella of what is referred to as OGC API. The OGC API standards are being developed through the Open Geospatial Consortium, that's the OGC, to make it easy for anyone to deploy and use geospatial data on the web. Today, we're going to focus on a USGS implementation of the OGC API Processes standard, and we'll talk about how it is used as part of the Network Linked Data Index. So you can learn more about OGC API at ogcapi.ogc.org, and some basic Googling will find a kind of plethora or a richness of additional information. The link on the screen will get you there, and I think it'll show up in the chat as well. So what specifically are we doing with OGC API Processes? As shown here, it's providing us access to a custom quote-unquote processing server, which houses utilities that integrate elevation data from multiple sources, hydrographic data from the Network Linked Data Index, other geospatial data, and information provided by a quote-unquote client. So the client submits information to the API Processes endpoint and executes some work. But so if we could do this with a custom API, what is OGC API Processes adding, right? We don't necessarily need the Processes API here. We could have crafted something ourselves. But it provides a standard or familiar and already documented API pattern that provides custom processing capabilities to a general audience. And we're able to leverage off of all that kind of already developed documentation and the familiarity of the toolchain that's being developed for OGC API Processes. So the processes we've implemented so far use elevation data to find a raindrop trace line, a split catchment, which is a polygon, or custom cross sections that can be retrieved for any user-defined line. The next 3 slides introduce these 3 algorithms. So this slide shows an example split catchment query. The blue pin on the map, you see here, is the latitude-longitude point passed in by the client. And in this case, the upstream process parameter is set to false, meaning that the upstream drainage basin is not included. So you see here, if the upstream drainage basin were included, we would include all of the drainage area upstream of this particular catchment. To get this result, the content shown on the left, this JSON content on the left, is posted. So post is a HTTP verb to the URL shown at the bottom of the screen here. The response is the data needed to create the yellow and green polygons on the map. The yellow being the local drainage area for the blue flow line, which exists from the NHD Plus version 2 dataset. And the green is the portion of the yellow polygon that's exclusively upstream of the blue pin. So that's what this split catchment algorithm actually does, is to generate the green polygon based on an elevation surface and the ability to delineate the split catchment. So we can split a catchment to resolve a watershed outlet precisely, which is great, but how do we make sure our point is actually along a flow line, or find a flow path that hasn't already been delineated in our source data set? In my live demo section, I'll illustrate the distinction there a little bit more. We have the flow trace algorithm, or raindrop trace algorithm, and it's used for both of these cases, finding the flow line, the intersection between a flow trace and an existing flow line, and finding the path from an existing point downstream to the nearest already delineated flow line. So given a point, the blue pin on the map, so up here, it follows a grid of elevation data downslope. So the red line on the map is that followed the path until it hits a flow line. The blue line on the map is the flow line, or the top of the flow line where it intersected. The NLDI itself uses this algorithm when a point is more than a few hundred meters from the nearest stream to develop to find the location along the river, and it's useful for a ton of other applications. This is a very common way to find a precise location on a flow line for later processing. And so the NLDI use case is important, the ability to find a location on the network, but it's just a start. At any network location, there's a lot going on. One of the most important things we're working on is providing cross sections at any location along a river network. And we'll show the details of this in a demo in just a second. So before we start the demo, I'm going to turn it back to Nicole for just a few minutes. So I'm going to stop sharing, and Nicole's going to take it from there.
Awesome. Thanks, Dave. Great. Give me just a second to share my content again. Perfect. Okay. All right. So, do you need programmatic access to USGS water data? Reproducible scripts for USGS water data? We want you to get involved with our API usability testing. Email wdfn_usability_testing@usgs.gov with the subject API usability testing. We want to know from you how easy it feels to get started using USGS APIs, if our docs make sense, and if our client libraries make it easier to use our systems. Check the WDFN blog for updates about future events that we'll host. All right, and that information will also be in the chat, so no worries if you don't grab this down. I'm going to go ahead and move to the next slide. We're going to do one last live poll, and then Dave is going to give us our first demo. So we're interested to hear, have you used any geospatial APIs before? It's not specific to USGS APIs like we've asked in previous webinars, but rather broadly, have you used any geospatial APIs before? There are a few ways that you can join this live poll. You can click the link that will be in the chat momentarily. You can take a picture of the QR code that's on your screen, or you can go to slido.com and use the code API. I love this response. I mean, I was the one that wrote the responses to these polls, but I love the fact that you're responding. No, I'm excited to try. I wonder what everyone else is going to say too. Let's see if we can get, let's see how many people are attending right now. Okay, so it looks like we have about 130 attendees. Let's see if we can get 50 to 60 responses to this particular poll before we move on. For the people who've responded with nope, never, or no, but I'm excited to try, we recognize that this API series can get pretty technical. So if this information is a little bit beyond your scope, but you're still interested in utilizing APIs to process USGS water data, send us an email at wdfn@usgs.gov and let us know what type of webinar, what type of content we could be providing to you so that we can make onboarding your experience a little bit easier for you. This poll's been fun. I feel like the responses have jumped around quite a bit. Who's going to be the ultimate leader? If you're interested in letting us know what other web service standards you have utilized, let us know in the chat. Use the Q&A function. Let us know what you've used or email us at wdfn@usgs.gov. All right, so it seems like our responses have started to stabilize here. Dave, whenever you're ready, welcome to start the demo.
Let me unmute. You all should have a browser again. And we'll jump in here. So a link to this repository in code.usgs.gov should be hitting the chat here momentarily. And this is where both of the demo, so we've got our Markdown document and a notebook that we're going to use for our demonstrations here. Both of them are checked in here, and there's a Jupyter environment that you can use to run all this code. So should be pretty set up. We may have a few changes to check in after we're done here because we got a few last minute changes, but nevertheless, in the next hour or so, this should all be updated. So just a note in terms of links to these resources, at the bottom of the blog post about this webinar, you'll see links to all this content in the resources section as well, and note that the recording will be available later. So the demo that I'm going to show is our Markdown document that I put together about the network link data index and OGC API processes. So I have it open in a few places here. I'll probably just walk through it in the HTML because I think this is the easiest to look at, and maybe just show briefly it in the our studio environment as well. But this demonstration, for this demonstration, we pull out a USGS site and just chose one that is useful for the demonstration. But this could be any USGS site, really, and they all have different characteristics. And this one illustrates the solution here well. So the first thing we do is use this R package, NHD plus tools, that some of you may be familiar with, and a function called plot NHD plus. And one of the things it is great for is just downloading a subset of data that you might want to look at and play with for visualization purposes. So here you can actually see I said actually plot is false. So all I'm using it for is grabbing plot data. And there's a secret little debug flag in NHD plus tools that allows me to print out web service calls. So you can see the web service calls that are being made here. So we're calling the network link data index for a basin with split catchment equals false in this case. We're calling a geospatial server for various layers. You can see here catchment SP, NHD flowline network, I'm actually going to make this slightly larger for everybody. We're NHD area, so we're getting all the different layers from the National Hydrography data set that we want to map up. NHD flowline non-network. And then there's a new function, shout out to Mike Johnson who contributed this, called map NHD plus. You can see here I'm passing in a cache object, which is the cached data that I just downloaded. So I don't have to re-download the data, and we can create a nice little Slippy map in Leaflet, which is handy. And so there's a little more description of what's going on here if you want to come back to this later and you want to dig into the nuances of some of the concepts here. But I'm going to just kind of keep on keeping on here. So the first thing I do is one of the things that came back from that data retrieval call, or the retrieval of spatial data, is a catchment layer. And see here, I'm saying I want the catchment feature ID equal to the COM ID of my outlet. So I'm grabbing the local catchment. So this little blue polygon here is the local drainage area for this one flow line, which our stream gauge is on, right? And so site data outlet COM ID, that's basically saying, look, the outlet of our site, or the outlet in our site data has an identifier. That's a river identifier. We've basically, and it's an established association between a stream gauge and a river. So we can pull out that one local drainage area for the flow line that our stream gauge is on. And we can see here, if we zoom in, there's some drainage area in this local catchment that's upstream of our stream gauge, and some drainage area that's downstream of our stream gauge, right? And so one of the things somebody might want to do, especially, this isn't super extreme, but there's other cases, and I'll illustrate one in a second, that are more extreme. You would really need to split this to be appropriate. So we might want to split off the bottom or the top, depending how we're looking at this. And that's what we can do down here. So you see, now I'm doing a get NLDI basin call, and I've set split to true. And you can see the URL. So this is the web service call. We've set split catchment to true. And in this case, instead of this lower grape polygon boundary, we got back this higher blue polygon boundary, which has split off the bottom of our local catchment. And so there's some magic going on behind the scenes here, obviously. And that's kind of what I want to show next. But to make this kind of make sense, I prepared a little bit of a contrived example. And so in this case, what I've done is so this point here, this 86, 505, 30, 606, is this one point up here. And we're far away from any local flow line, right? We're up near a watershed divide. So we're looking at, this is a catchment that we're going to be looking at. And so this is the local drainage area for this one long flow line. And I'm using this starting point way up near the boundary of our catchment. And so if we come on down here, the first thing I'm doing is calling get raindrop trace. And this is calling that raindrop trace OGC API processes algorithm directly. So you can see our URL here, NLDI flow trace execution, and our input is some JSON. And so this, for most folks on the line, I hope is somewhat familiar, but basically this is a list. This is an object. It's a list of structured objects that are inputs. They have an ID, so lat, lon, raindrop trace, direction. They have a type. These are all text plain type, and there's a value for that little object. Right? So we've got our point location. We've set raindrop trace to true. And we have our direction set to down, right? And so this gave us back a trace, which I'm actually going to step over to another browser and show a little bit of how that would work. So what we're looking at now is called Swagger. I'm not going to go into great detail here, but this is an API documentation platform or standard. And we can look at any one of these endpoints, right? There's a processes NLDI flow trace endpoint that allows you to get metadata about the NLDI flow trace process. There's another endpoint called execution that supports, as you remember, I mentioned the post verb. It supports post. And there's a little, so if I hit cancel here, this would switch to a try it out button. But so we're in the try it out mode. And you can see here, I've actually pasted in the JSON that I had right here. So this is that same JSON content from our demo. And so this is what R is creating and passing to the server. So now we're going to jump back over here. And I've already run all this, but I'll go ahead and if we hit execute here, this just quote unquote posted this JSON to a server or to the server to this endpoint. And what we got back, here's the response body. We got it back a 200, which is the HTTP response code for success. We got back this response body, which is a GeoJSON feature collection, and some headers. So that's cool. I could copy this and jump over to another app to visualize it. So I've already got that in here, and you can see we got our flow trace, right? Let's look at satellite maybe. You can see our flow trace. And I think this is a nice illustration because the existing flow line is along this green path here, right? And we selected a point up near a catchment boundary up here somewhere, and there was no flow line for, clearly there's a little low area of, green vegetation along the landscape here that's not in the NHD plus medium res network, which is what the NLDI is based on. But if we wanted to know how water got from up here to the river, we could generate that trace with this algorithm, right? So that's really what's going on in the background, right? We pick a point, we tell it how we want it to go downstream, and we get back some information. So cool. And just to kind of tie this up quickly, the PyGeo API that we're working with, this API, NLDI PyGeo API endpoint at labs.waterdata.usgs.gov, to get to that Swagger documentation, there's API documentation, Swagger UI. And this is where you find all the documentation of these endpoints, just to kind of make that traversable for everybody. Okay, so using that flow trace, and one of the things we got back from this flow trace is, so let's see, what are we doing next? So one of the things we got back from the flow trace is an intersection point between the raindrop line that was delineated along elevation and the existing flow lines. But before we go there, we're going to run this split catchment. And this illustrates kind of what the split catchment is actually doing in the background. We're going to run the split catchment for the original point. So this point object here is what we used in the original get raindrop trace. So this is this point up near the watershed divide. It's not a point down near the flow line. So by running this basin point against get split catchment, so this is the API processes algorithm to actually run a split catchment, we get back something kind of interesting. So here's a little Slippy map showing us our raindrop trace, the intersection. So here's let me see if I have the layer. Here's our flow line network. You can see our full flow line network and the intersection point between our raindrop trace and the river network. Turn that back off. Well, our split catchment polygon is just the area of the catchment upstream of the point we started at. So we just got this tiny little basin, right? And so what that's saying is the area upstream of this point is here. The area downstream of this point is everything else that was part of the catchment. So if we were to come back and turn catchments on, you'd see this little basin has a shared boundary with the overall catchment, but it's a tiny little subset of it, right? So this is all that split catchment algorithm really does, is it generates a portion of the catchment upstream of a point. And if the point happens to be down here on the flow line of the catchment, you get a kind of a catchment that's been split in half, right? But you have to use this point very precisely to get the catchment split in half. So this is just a little bit nicer visualization of that result, showing how, we have our raindrop trace that gets you out of the catchment. We have our existing flow line network, and we have this little small drainage basin up in the kind of headland area of our catchment. But But then I guess the last thing I want to show, and then I'll turn it over to Rich to talk a little bit about cross sections, is how we can call the split catchment directly for a point. So in this case, so here we've got basin split. We're calling it with our basin split point. And notice notice I've got a little commented out. I can't actually use this because we're working out some edge cases of our flow line geometry and elevation data. We've got a bug fix kind of in the works that's about to be deployed. But I did need to nudge this point just a tiny hair to get it to fall into the right elevation cell to get this to work. This is not going to happen everywhere, but it's an outstanding issue that's being worked. So we've got our point that is essentially the same as that intersection point that was found, just nudged by like a 100th or 1,000th of a degree. And then we're passing that into get split catchment. So this is, again, the post to a URL, in this case, the NLDI split catchment execution endpoint, and we've got some JSON that we passed in. So that's in this tab. So here's our Swagger documentation for processes NLDI split catchment execution. And I've pasted in that JSON, and we can hit execute. And so we got back a feature collection again. I could copy this, take a look at it over here. And you can see we actually got back a few things. It's a little hard to see in this view, but if we jump, so there's actually 3 polygons here. There's a drainage basin, which is the whole outer polygon, and there's a split. Basically, there's a pair of polygons for the split catchment. So if we jump back over here and take a look, we can see here's that area upstream of the intersection point. So that's this green polygon. And we also, so I guess I don't have that to turn on. I'm going to jump over to R where I prepared another map for this. So actually, this is a good point. The HTML that I've just been showing was rendered with R Markdown. This is the source file for that HTML. If I were to just click knit here, it would create that HTML file. And so all of these are going to be pretty familiar. These maps are the things that I worked through. There's some different versions of them that are rendered with just plain plot, if you'd want to kind of come in and see how that works. But the thing I really wanted to show is, yeah, this here. Okay, so we have, I'm going to turn off a few things here. And so if we turn off split catchment, that's or split basin, that's our basin that was returned upstream of this intersection point. And then the split catchment is this thing in yellow, showing that was the catchment that we started with that got split, right? So we kind of split off the top of that catchment and combined it with its upstream basin, and ta-da, we can create that split basin directly. So that's pretty much what I had. And so this is all summarized. Obviously there's a few things I've modified over there in RStudio, and we'll get that latest R Markdown checked in and available on our API process demo repository. Feel free to reach out directly with questions. I'm happy to follow up with people with any questions and ideas or anything. And everything should be linked in the resources section of our blog posts at the end of the day here. So with that, I think I am going to stop sharing content and pass it over to Rich McDonald. Thanks, Rich. Oh, you're muted. Still can't hear you.
Share my screen here.
There we go. Now we got you.
Are we good? Okay, so in addition to the process API and clients, for example, the R client that Dave demonstrated, the code that we use for the process itself is also available, in this case, as a Python package. And I'm just going to quickly demonstrate that the process to get a cross-section at endpoints you can also implement that in your own workflow as a function available in the NLDI cross-section tool code package. In this case, I'm going to be demonstrating some work we did a while ago where we were trying to provide some context to USGS gauges and to the stage at those gauges. So I've got two dictionaries here, a gauge path, which simply defines two Latin law endpoints at a gauge location, and these thresholds, and the thresholds contain a gauge stage at some location. For example, it could be a road or it could be the top of a bank. And we're going to use that get cross-section at endpoints function. We're going to pass it the path. We're going to pass it the number of points and some resolution. And we can then look at that data both on a map. So we have our USGS gauge location here. We've got a bank full location, a street location, and if we use the code to extract the cross section, we can overlay the elevations of the street and the bank full location to provide some topographic context to the values of stage at that gauge location. So, but we also can use the process itself. And so here I'm just going into the same Swagger documentation that Dave was illustrating earlier. And I'm just going to use the default example that's in the Swagger document using that try it out button, and I'm going to execute the function. Here we have in our JSON, we're supplying a list of lat and lon locations, just like the function requires, the number of points in the returned cross section, and the resolution, the topographic resolution that we get from that function. And here's the return. It has a number of features, and for each feature there is a distance from the endpoint and the elevation. So I can copy that and throw it into the JSON function here, and you can see it returns that cross-section at those endpoints. And again, each endpoint has a distance and an elevation. So again, we'll make these demos available in that repository that Dave mentioned earlier. And also, if you have any questions, please don't hesitate to reach out. So that's my quick demo. I'll pass it back.
Awesome, thank you, Rich. And I just want to make one kind of comment as we move on to the Q&A, and that's that what Rich just showed is really an illustration of a pattern we're pursuing where we can wrap nice example software or nice software that people want to use via web services in this OGC API Processes kind of wrapper server platform, and provide the data and environment to anybody who wants to use it on the web, and not require them to load up a full environment locally to be able to run these capabilities. But what's really cool about that is we can take contributions to these services through normal Python packages. So if this is happening with some of our colleagues around kind of academic spheres, where we're able to triage bugs and work on issues in the package and then promote those to production as processes. So that pattern has been a really nice thing to pursue. I just want to make it clear that that's what Rich was just showing, is running his package code as a demo and then calling the same thing as a web service, where he didn't need that environment locally for the service version. So.
All right, thank you so much, Rich and Dave, for both of those really great demos. So we're gonna start the Q&A portion of this talk right now. So the first question that we had come in is for Dave. The resolution looks a bit coarse in regards to the flow lines, medium resolution. Why not HR? This is regarding the first demo. Go ahead, Dave.
Yeah, no, thanks for the question. This is very top of mind. So the why not HR is really a matter of maturity of the data. If you go back to those two GIFs that Jim Kreft showed early on, especially the one that shows the kind of full national connectivity of the network, we feel pretty strongly that the network needs to hang together at a national scale, from the bottom up in a way that's really concrete and really representative. And unfortunately, the locally developed 24K kind of hydrography of the NHT plus high res has a lot of kind of glitchy discontinuities and things that at a local scale for any given application aren't a huge issue, but in kind of total become enough of a problem that we basically just need to do some more work to be ready to roll that out at a national scale. And to extend that a little bit, going up in order of magnitude and number of features is not a small deal. We're talking an order of magnitude more data, order of magnitude more feature identifiers, order of magnitude more edge cases to deal with. It's a lot. So that's why not, right? The medium res network has been worked over and over and over by teams like the National Water Quality Assessment. The National Water Model has done a tremendous amount of work quality controlling that network, and others. The EPA folks have been working with NHT Plus for a long time to ensure that it's representative for the country, and the HR network just hasn't gotten that level of scrutiny yet. So that's really the why not. But it's coming. It's top of list for us to work on conflating medium res network and the quality of the medium res network with the high res geometry and the underlying kind of content of the high res network. So it's going to be a bit, but we're definitely working on it.
Great. Thanks for that, Dave. Okay, so we don't have any other questions that have come in yet, but I see that there are still 101 people who are in this live event. So what are your questions? We would like to answer them. Okay, great. Here's another one. Thank you. This may be rather unrelated to today's webinar, but will NPDES point sources return as an option to NLDI queries? Dave, did you want to take that one?
Sure. Yeah. No, it's not totally unrelated. And actually, NPDES, that's a hard one, was one of our earliest kind of test demo sets with the EPA in the Network Link Data Index. And it's kind of an outstanding one to bring back at this point. There's a lot of work ongoing, and this is probably a good opportunity for me to kind of make a plug. If there are Network Link Data Index layers that you would like to see added, please consider opening issues in the NLDI services repository. So we've actually very recently moved to the Network Link Data Index from an old federal advisory committee based GitHub organization to a new Internet of Water GitHub organization. And we're hoping to use the NLDI services, NLDI-services in the Internet of Water GitHub organization. We're hoping to use that issue tracker as a real place to kind of gather ideas and momentum behind kind of new developments. So I would encourage folks to open up issues there if you have these kinds of questions. There's another project under the Internet of Water organization called GeoConnects, where some of this can also get done because the two systems are quite related. If you scan back through some of the older water data blogs, the relationship between these systems is described there. And I would encourage you to engage in the GitHub issues on either the NLDI services or the GeoConnects repository.
Great, thanks. Thanks, Dave. Okay, any other questions? If there aren't any other questions from the audience right now, the question I would like to pose to the audience is, how was today's webinar? Was today's webinar meeting you where you're at? Was it too technical? Do you want more information? Do you want to connect with us more? Regardless of what your answer is to that question or those series of questions, send us an email at wdfn@usgs.gov so that we can hear from you. In the meantime, while we still have a few minutes left, I encourage any attendees to put questions into the Slido or use the Q&A feature in the Teams live event. If there aren't any other questions that come in the next few minutes, Dave, is there anything else that you would like to say, or any of our other panelists?
I think I wanted to plug this move to the Internet of Water as the network link data index kind of home. The concept with a lot of these services that we're rolling out in the water data space is that they're things we will use as USGS kind of information delivery folks. They're things we will build as members of the community, and they're potentially kind of community assets. They're potentially open, not just open source, but actually projects that are maintained by the community. And so if you look at the Internet of Water kind of paradigm, that's how this is all supposed to come together, and it'll be Internet of Water capabilities hosted by the U.S. Geological Survey. And the network link data index in particular is coming together that way. And I would expect to see some of these geoprocessing kind of capabilities also go that way. So if there are especially compelling additional functionalities that we could be adding here that would fit in the context of water data services and the network link data index kind of paradigm that folks in the community have developed and would like to contribute, let us know. Get in touch. We're really excited to leverage off other people's work where we can to offer as much value as we can to the community, as well as to build in greater value to the site pages that we put together and various information systems that we're maintaining here as a USGS kind of community. So I think that's what I would kind of add beyond anything we've discussed thus far. I hope this was useful for folks. This has been a big deadline for a number of us here to get a few things out the door, which has been useful from my perspective. And as long as it wasn't a waste of time for everybody else, I'm happy. So.
Thanks, Dave. Yeah, that's really helpful to add. Well, we don't have any other questions that have come in, so I'm going to go ahead and say thank you so much to everyone for attending today's live webinar. If there are any questions that arise for you after the fact, you know where to email us, wdfn@usgs.gov. The recording of this webinar will be available on the USGS YouTube channel and on the blog post that we linked in the chat earlier today and on the Water Resources Mission Area website in about 1 week. So check back for that. Otherwise, thank you so much and have a great day.